This video is on naming alkynes. And again, as always, take notes while you're watching this. If you need to do a few more examples, you can always check in your book. But alkynes are hydrocarbons that have a triple bond. They usually have one, but they could have more triple bonds. And in that general formula, they would have the formula CnH2n-2. Because a triple bond is a linear formula, when you make a triple bond, you will have a linear molecule. There will be no cis or trans isomers in triple bonds. So alkynes are named the same way as you named alkenes, only change the ending to YNE, pronounced "ine," instead of using ENE. So the rules are here. Determine the longest continuous chain of carbons that have the triple bond between two of its carbons. So that's key. You need to make sure that the parent chain includes the triple bond. And then you're going to number the carbons so that the triple bond has the lowest set of numbers. And then, lastly, like always, identify any branching groups that are attached to the parent chain and identify those by name and location as well. So hopefully you're getting fairly comfortable with this process at this point, and so we're going to just jump into some examples. So if you look at the first example, it says, name the following. Again, you can pause your video at any time to test yourself and then check your answers by pressing play. But if you look at this example, there are only 2 carbons, okay? So if you look at that, there are only 2 carbons. The triple bond has to be between the 1 and the 2. So we would just say F for 2 carbons, and then we would, because of the triple bond, change the ending to "ine." There are no other substituent groups added. On our second example, it says to draw a structure for propyne. Prop means that we have 3 carbons. So if we draw our 3 carbons, and much like when we had a double bond, when you have a triple bond, if you put it between either carbon, it's going to be considered the 1 carbon. So we don't say 1 propyne because that's redundant. We just say propyne. So the only thing left is to identify the H's. If you look here where the triple bond is, this can only hold 1 more H. You could easily draw it like this structure up above as well. This middle carbon right here is making as many bonds as it possibly can, a total of 4, so we can't add any more H's to that one. And on the end carbon, it's only making 1, so we can add 3 more H's. Moving on to our next example, I want you to try to name the following. Again, if you want to test yourself, press pause. But what you would do on this particular example is, you remember you have to number the carbon chain. You have to number it so that it contains the triple bond. Now, a lot of students will do this, and if you count, this would be 1, 2, 3, 4, 5, and 6. But I would always double check to see if there's not another way you can do this. And if you look here, it'd be 1, 2, 3, 4, 5, 6. So it's the same either way, so you could stick with your blue numbering system. And we want to make sure that we number it so that that triple bond has the 1 and not the 6. Now, if you look at that one, what you would identify off of the parent chain here would be this group. Now, because there are 3 carbons in this group, this would be a propyl group. So in naming this one, your parent chain has 6 carbons, so you would say hex for the prefix indicating 6 carbons. You'd say YNE as the suffix to indicate the triple bond. The triple bond is located on the 1 carbon, so 1 hexyne, and then we have a 3 propyl group. So 3 propyl, 1 hexyne is the name on that example. And then our last example for the video is to draw a structure for 4-methyl-2-pentyne. So we'd start at the back of the name. We know we're going to have a triple bond, with 5 carbons. So we're going to draw 1, 2, 3, 4, and 5 carbons. That triple bond is located on the 2 carbons. So here on the 1, 2, we're going to draw a triple bond. On our 4th carbon over, 1, 2, 3, 4, we're going to put a methyl group, which is a CH3 group. And that takes care of any of our additional substituents or triple bonds. So now your only job is to determine how many H's are remaining on the other carbons here. So on this end carbon, we're only making 1 bond right now, so we have room for 3 more. The second carbon over has 4 bonds already, so does the third, so we wouldn't put H's on either of those two. On the fourth carbon, you have room for 1 more H, and on the fifth carbon, you have room for 3 more H's. And that should be a pretty good overview of how you would name an alkyne.